talked to my honors seminar on algorithmic bias this spring, and I thought he would be a really good choice for this talk. It was very interesting. Um, Dr. Kushni received his bachelor's science degree magna cum laude from from Cornell in 2004, SM degree in 2006, and PhD in 2010, both in EE and computer science from MIT. While at MIT, he was a National Science Foundation Graduate Research Fellow. Dr. Varshney is a distinguished research staff member and manager with IBM Research at the TJ Watson Research Center in Yorktown Heights, where he leads the machine learning group in Foundations of Trustworthy AI. He was a visiting scientist at IBM Research Africa, Nairobi, Kenya in 2019. He is the founding co-director of the IBM Science for Social Good initiative. He applies data science and predictive analytics to human capital management, healthcare, olfactation, computational creativity, public affairs, international development, and algorithmic fairness, which has led to recognitions such as the 2013 Gerstner Award for Client Excellence for contributions to the WellPoint team and the extraordinary IBM Research Technical Accomplishment for contributions to workforce innovation and enterprise transformation. He conducts academic research on the theory and methods of trustworthy machine learning. His work has been recognized through Best Paper Awards at Fusion 2009, Soli 2013, KDD 2014, SDM 2015, and the 2019 Computing Community Consortium Schmidt Futures Computer Science for Social Good White Paper Competition. He is currently writing a book entitled Trustworthy Machine Learning with Manning Publications. He is senior member of the IEEE and a member of the Partnership on AI Safety Critical AI Expert Group. Dr. Varshney.
All right, thank you, Kevin. That was a very long introduction, but yeah, I'm very happy to be here. Yeah, I mean, please interrupt anytime. I'm happy to make this more of a discussion as well. Okay. The topic is developing trust in artificial intelligence and machine learning for high stakes applications, and we'll unpack that as we go along, right? So just as some intro sort of motivation, right? So just a couple of months ago, what happened was in the UK, they have this national sort of exam for high school, I think, and it's called the A levels, and they couldn't conduct it in person because of COVID. So what they did instead was they actually asked an algorithm to predict what each student would have scored on the exam if they had taken it, and that's really weird. But anyways, what happened was that students who were studying at schools that have traditionally performed poorly also had poor predicted scores. So it was almost like it didn't matter what the student his background or aptitude was. If they studied at a poor performing school, they would get a poor predicted score. And obviously that's quite unfair and very biased. Okay. As another example, a couple of years ago, there was a fatality in one of Uber's self-driving vehicles, and it hit a bicyclist. And the reason for that was that its false positive rate was not particularly set well. So it was a very technical sort of issue that led to that. Another example comes from criminal justice in the United States. So there's an algorithm called Compass, which is used by many jurisdictions throughout the US in the criminal justice setting for pretrial detention decisions, for sentencing decisions, and so forth. And it's been investigated and shown to actually have several racial biases as well as gender biases. And as another example, this is actually from a paper rather than a news article. So in a healthcare setting, if you have a machine learning or AI system that's trying to predict whether a patient has pneumonia or not, a particular model trained for a particular hospital had this rule that someone who has asthma has a lower risk of having pneumonia. And That's pretty weird. People who have asthma should actually have a higher risk of getting pneumonia. And so what was happening in this particular hospital was that they had a special program where anyone who did have asthma would be treated specially. And so in this hospital, it was actually true, but picking up on these weird sort of quirks of the data isn't going to generalize if you look at any other hospital, which doesn't have that special program. Okay. So all of this is kind of introduction into the fact that there's all sorts of weird things that can happen in machine learning, and we need to be aware of them, right? And as we're all starting to understand and realize, AI is now being used in many high-stakes decision-making applications. That could be if you're applying for a loan at the bank. It could be whether you're applying for a job. This picture, by the way, is where I normally work, but I haven't been in 7 months. So that is the TJ Watson Research Center. It could be in college admissions. It could be in the criminal justice system, as I said before, right? And many other high-stakes applications. And now the question is, what does it take to trust a decision made by a machine? So being accurate, being even 99% accurate isn't good enough when we are using these in very important sort of things that have a profound effect on people's lives. So we want to ask the question, is it fair? Is it easy to understand? So can people understand how the algorithm makes its decisions? Are we able to figure out if someone has tampered with it and whether it's accountable or not? Okay. And why do we want this trust, right? So a decision aid, no matter how sophisticated or intelligent it may be rejected by a decision maker who does not trust it, and so its potential benefits to system performance will be lost. So that's kind of a quote from a psychologist at the University of Toronto, but I think all of us kind of understand this, right? And another thing to say is a quote from Thomas J. Watson Sr., who was one of the early CEOs of IBM, that the toughest thing about the power of trust is that it's very difficult to build and very easy to destroy. So in this presentation, I'm not going to talk about destroying the trust, really talk more about building the trust, okay? So let's get into this, okay? So first of all, what is trust, right? It's this weird word. All of us kind of have a sense of what it means, but we might not have actually thought about it in more detail. That what is trust and what does it mean to be trustworthy? So it turns out that in the organizational management literature, they've come up with these 4 attributes of trustworthy people. So the first is that the person is credible or competent at what they're doing. Second is that that competence remains true in different sort of conditions, different settings, and so forth. The third is that they're open or intimate, so you can communicate back and forth with that person. And the fourth is that they're somewhat selfless, that they have goals that extend beyond themselves, that they're not just trying to do things that are only in their own self-interest. Okay. So this is for people, and it actually is true that these are the same characteristics or attributes that you want for a machine learning system or an AI system as well to be trustworthy. Okay. And how this maps to precise sort of things in AI is as follows. So if we want that credible or competent system, we do want it to have high accuracy, that it's predicting well, but that's not enough, right? So on the reliability side, we want these machine learning systems to be fair, robust, and safe. In terms of openness, we want them to be explainable, that we as people can understand how it is that they make their decisions. And we want transparency into the overall sort of system. How is it, I mean, what process did it go through? What was the life cycle? What data did it have? What test results did it have throughout the entire process? Okay. And we want it to be selfless. So we want there to be what's called value alignment. We want the AI system to behave in such ways that are consistent with the values of society. And we also want to use AI for social good applications. Okay. All right, so this is kind of the sort of things that we want, and how do we get into more detail about them? And one way I've found works well to explain this is actually through analogy to a different industry that was new at its time. So these days, AI is kind of new in the sense of being widely used in all sorts of endeavors of human life. Back in the late 1800s, processed food was a very new concept that people had never really thought about before. That oh, really? You can buy food that's already been cooked and just start eating it. That was really weird for people at that time. So a lot of the food processing manufacturers at that time, and the Heinz company is a great example, did a lot to try to increase the trust in their products. Okay? So the Heinz company specifically, and I'm not a paid advertiser spokesperson for Heinz, but it's a great example. So they were one of the first to guarantee that they're not going to be using adulterated ingredients in their sauces and ketchups and stuff. So at that time, other folks were putting like wood pulp and other things into their ketchups. Right. They were the first to offer their ketchup in transparent glass containers, whereas other people were selling their sauces in dark, the opaque sort of containers. They did a lot on innovating sanitary food preparation. They were the first company to actually offer free factory tours open to the public. And then they lobbied for the Pure Food and Drug Act of 1905, which later on led to further regulations like requirements for labeling of food, of tamper-resistant packaging, and so forth. And they also had a social mission that they wanted to free up time for people, homemakers especially, to be able to have leisure time or do other things. Okay? And at that time, it was also true that there was a tradition of muckraking which was starting. So activists and journalists were investigating uh, this processed food industry and trying to illuminate the ills of it. So there's a very famous novel called The Jungle by Upton Sinclair, which precisely does this. And today, that tradition continues for AI. So there's a pretty nice book called Weapons of Math Destruction, so math instead of mass, by Kathy O'Neill, and it points out many of the same things with problems with AI, similar to the ones I showed at the beginning. And she does place herself into that muckraking tradition, right? And then the picture on the right is of a researcher who used to be with MIT Media Lab until very recently. And she has her own sort of organization now called the Algorithmic Justice League, and her name is Joy Bulamwini. And I'll get back to her story in the last part of the presentation. Go. So we have this analogy, right, of processed food to AI in terms of the muckraking. So what is the analogy in the actual technical aspects, right? So when we talk about unadulterated ingredients, we should also be talking about the quality of the data that we're feeding into AI. When we talk about tamper-resistant packaging, we should be thinking about how to prevent data poisoning attacks and adversarial attacks and so forth. When we're talking about the clear plastic, or sorry, clear glass uh, containers for the ketchup, that's like interpretability or explainability of machine learning models that we can understand how it is that they work. When we're talking about free factory tours, that's like having some sort of transparent reporting mechanisms and fact sheets, something that I'll discuss in a little bit. When we're talking about lobbying, that's happening these days as well, and having a social mission is precisely the why we do AI for social good. So just going into a little bit more detail on these things. So data quality. So these days, you need a lot of data to train machine learning models to do a good job. And a lot of that data comes from us, from people. Sometimes just naturally when you click on stuff on Facebook or Google or stuff like that, but also there's a lot of what's called crowdsourcing. So you have people who whose job it is to click on stuff, label stuff, and so forth. And you can have some people who are just clueless and they give you bad data. Some people who are actually trying to game the system, fool you, or do something malicious, who are giving you bad data. So data quality can be a sort of big problem, right? Value alignment is the idea that we as people, we as society should be determining or feeding in our values into how machine learning and AI systems behave. So the picture on the left is something that was also done at the MIT Media Lab. It was called the Moral Machine Project. And they had people give a lot of, and lots of people, it's like hundreds of thousands of people give judgments on what are so-called trolley problems. If you have a car driving down the road, you have a choice to keep going straight and kill the people on the left, or you make a turn and you kill the people on the right. What do you do? And those people are different. There can be different in number, different in age, different in other characteristics, and so forth. And by getting all these value judgments from people, you can start understanding what an AI system might want to do. Right, and then the picture on the right is a illustration of King Midas, who received this supposedly good thing that he could wish for anything that he wanted. And what he chose is that anything that he touched would turn to gold. But that was a very poorly specified sort of request, because even like the food that he touched turned to gold and he couldn't eat. So while you can, I mean, instruct AI, it's very important to make that specification very precise, because incorrectly specified values can lead to all sorts of weird behaviors, because AI can just optimize what it's trying to optimize. Right? Another thing in machine learning is distribution shift. So if the training data that you trained on doesn't match the data that you are actually hoping to run that model on, if it's changed in some way, then you can have a lot of problems. Right? There's different types of shift, but let me not go into that level of detail. And then you have the more adversarial sort of things that can happen. So you have people who are trying to attack you and do malicious stuff. So the picture on the left is a stop sign with some particularly special sort of markings on it. To a regular person, it would just seem like, yeah, someone was just, I mean, being playful or whatever. But these sort of messages can be particularly very specially coded, so that that stop sign actually to the AI looks like a speed limit sign or something else. You can also make very minor sort of changes to an image that are not perceptible by a human, and it doesn't just have to be images, but other things, and they actually move you away from what the classifier or the AI system thinks it is. So you can make an ostrich image look like anything else that you want, whether it's a vacuum cleaner or a shoe shop or pretty much anything. So this is another sort of malicious attack. Okay. And then another important thing is the fairness. So if any of you have kind of read anything about machine learning, you sometimes hear the word discriminative or discrimination. That's actually not necessarily a bad thing. Discrimination is just the idea that you can tell things apart. So your favorite wine snob has a discriminative palate. That's not bad, right? They can just tell the difference between different wines. That's what we want a machine learning system to do. But the problem is when that discrimination places certain privileged groups at systematic advantage and certain unprivileged groups at systematic disadvantage. And this happens when we have unwanted bias in the training data, and it yields unwanted bias in the models that we have. And this can come from prejudice in the labels. So if you've if you're getting humans to give you the judgments from the past historical data, maybe it was a loan officer who had categorized that these people are eligible for a loan and these ones are not. They might have had some implicit biases in their mind so that they were not completely fair in giving those loans out. You can have under or over sampling, so you can have certain populations who are less just in your data than others. You can have problem specification problems. So just asking the machine to do the wrong things and introduce biases in the data preparation that you do as well. And then there's the next aspect, which is interpretability or explainability. What you want is for people to be able to understand how it is that machine learning systems make their decisions. So there's various ways to do this. You can do this directly by using a model that people can just understand themselves, like decision trees or decision rules and so forth. Or you can do it after the fact. So if you have a complicated model like a neural network that no one is able to understand, then you can build a simple model that tries to explain it. There's global explanations trying to understand the entire model at once. There's local instance level explanations. So why did I get denied for my particular loan application? I don't care about how it works for everyone, right? And then there's static versus interactive. So how can I ask the system in an interactive fashion or not? Okay. Next topic is fact sheets, and oops, sorry. And this is the idea that we want to understand how it is that the overall system is put together and what sort of tests it's undergone and so forth. It's not a very complicated idea, but it's very lacking in AI right now. So in many different industries, this is very standard. So the image I have on the screen is if you go to the car dealership and you look in the sticker of a new car, look at the sticker of the new car, it has the test results like fuel economy, not just on average, but in different operating conditions. It has what features does it have, what test results has it undergone, and so forth, right? And that's exactly what we want for AI systems as well. And we're trying to push this quite a bit to see where it can go. And for general engineering folks, I mean, I think this would seem like very natural, but it's not the case right now in AI. And there's another sort of related effort out of Microsoft called data sheets for data sets, and their motivation is exactly the data sheets that are associated with, I don't know, like capacitors and resistors and integrated circuits and stuff. So this is not a new idea, but it's being applied in AI. Okay. Another next thing is with kind of the lobbying or regulatory affairs and so forth. So this is a kind of interesting sort of thing. So just as an example, Microsoft uh, in December of 2018 was really lobbying, we need to regulate AI, we need to regulate all this other stuff. And then just like 3 months later, they were like, yeah, we should be regulating, but not exactly like fully, just in the way we want it and so forth. So it's a very interesting sort of space that companies are pushing for regulation, for having all these trust sort of things, but then they're not going all out about it, right? And then the last one was this was social good, right? So these are some of the projects that we in our program have run with various sort of organizations. I'm not going to go in detail here, but just emphasizing the point that it is possible to use machine learning and AI in very societally relevant problems that relate to poverty, hunger, health, education, the environment, and inequalities of various sorts. Cool. Right, so just for the last few minutes before wrapping up, just wanted to give you one example of some work that we did that relates to Joy Buolamwini's work, the MIT Media Lab researcher from the Algorithmic Justice League that I mentioned before, right? Her work is related to face recognition. So there's lots of different computer vision tasks that deal with faces. And these days, the best algorithms for all of them are based on what are called deep neural networks. So there's the face detection task. So on this image, can you identify all the faces that exist? This particular image is from the Academy Awards a few years ago when Ellen supposedly broke the internet. And one thing you can notice is that the image, or one of the faces in the top right has been missed, right? Then there's the attribute classification task. So if you are given a face, can you estimate or predict different attributes about it? That could be whether the person is smiling or not, what their age is, whether they're wearing glasses or not, what race or ethnicity they are, what their gender is, and so forth. Then there's the verification task. So I have given the system my picture from a few weeks ago, and now I show up and it needs to verify, am I the same person? And if I'm not Harrison Ford and I show up, it'll realize that I'm not, right? And then there's the recognition task, which is you have a database of like thousands or millions of people, and you're trying to figure out who I am, right? Okay, so what Joy Bulamwini did was some work on this detection task, but what I'm going to talk about is on this attribute classification task. Okay. So what she showed back in 2000, late 2017, early 2018 was that if you are looking at the gender classification task, so you have a face and it's trying to predict whether the face corresponds to a male or female. That task is a little bit flawed because of non-binary genders and so forth, but let's assume that that is a valid task. Then she analyzed three commercial face classifiers, one from Face++, one from Microsoft, and one from IBM. And what she showed was that the error rate for dark-skinned females was much higher in all three corporations, systems than it was for dark-skinned males, light-skinned females, and light-skinned males. Okay. And then what happened, I was actually involved in the response at that time, is that all of these companies, I was involved with IBM specifically, all of these companies improved their systems quite a bit so that their performance on dark-skinned females was quite a bit resolved and much more similar to these as if these other groups, right? But then she had some follow-up work with another collaborator, Debaraji, in which then they looked at these two other corporations, Amazon and Kairos, and they continued to have very poor performance on dark-skinned females, right? So what after, I mean, this first thing that happened, one thing that we wanted to understand a little bit more was why is this happening? Why are the dark-skinned females having worse performance on this gender classification task? Okay. And the first thing that we thought about is it's probably about the skin type, the skin color. I mean, what else could it be, right? But we wanted to test that out. So this is what we did. So we were able to replicate their work, Balamani and Gebru, and we had a very similar sort of thing that the dark-skinned females had a much higher error rate in the gender classification task than the light-skinned females, dark-skinned males, or light-skinned males. With these images, the label underneath the image is the predicted label. Okay. All right, so that's fine. We were able to reproduce it, but now why is that the case? Okay. So what we tried to do was to see if that unequal performance is because of the skin tone. Then we should be able to get rid of that inequality by making the neural network invariant to the skin tone using some color theory sort of things. And specifically, what we did was we lightened or darkened the skin tone in various face images and experimented with what the result would be in the classification performance. And we did this in two different ways. The details aren't so important, but we were able to, in a mathematical sense, change the skin color of faces. And what happened was that when we lightened or darkened the images, there was no significant effect at all on the darkening or the lightening on the classifier performance. And so we were able to conclude that skin type is not the reason for what was going on. So then we had a new hypothesis. In doing the work, we had noticed that most of the misclassified dark-skinned females have short hair. So these were all incorrect classifications. And in fact, 29 of the 33 had short hair. These were all correctly classified dark-skinned females as females. Okay? And so we labeled all the images in the data set with their hair length and found that, yes, 25% error rate on dark-skinned short-haired females, uh, whereas only 8% error rate on dark-skinned long-haired females. And this was also true in the light-skinned, so much higher error rate on short-haired females than long-haired females. Okay, so now we want to see, is this really what's the cause or not, okay? So what we did was now we looked at face classifiers that only were looking at images in this part of the face without any hair showing. So we cropped those images, and what happened was we continued to have exactly the same unequal classifier performance across the groups. And so hair length was not the reason either. Okay. And then finally, the next thing that we did was use something called the contrastive explanations method, which our group had recently developed at that point in time. And we were able to highlight what in the image is the classifier focusing in on in order to make its classifications. And if we look at the females, it was focusing in on much more on the eyes and the lips and a little bit on the cheeks and on the males on the nose and so forth. All right. So on the right is kind of the average of what the classifier was focusing in on, and as you can see, there's many times sort of like eye makeup and lip makeup and sometimes cheek makeup, right? So what happened was, in sort of summary, that it wasn't the skin type by itself. And we should have maybe guessed this before we even started the work, because the dark-skinned males' accuracy was actually on par with the light-skinned males before. It wasn't the hair length by itself either. It was facial features like these red and pink lips, the cheeks, and eye makeup. And why is this happening, right? So our conjecture was uh, that this is because most of these commercial, not most, I guess all of these commercial classifiers for face attributes are based on celebrity images, because it's easy to get, without copyright issues and consent issues, a large corpus of celebrity images. And there's a much more mismatch between what dark-skinned female regular people and dark-skinned female celebrities look like as compared to any other group. So that was the main culprit. Okay? So what that implies is, to do a better job, we really should be collecting much more diverse set of training data, so that we're not baking in certain stereotypes into our models. Right? So before wrapping up, just two further comments. One is that this face recognition space is actually pretty dangerous, because uh, it can be used in ways that oppress various sort of groups and minorities and so forth. So if you're doing surveillance of people and things like that, it can really be misused. So it can be a very much human rights sort of issue. So IBM earlier this year declared that we're completely out of this face recognition space, right? And other companies followed quickly. So Amazon and I think it was Microsoft. They made somewhat softer sort of statements, but they're also somewhat out of the space. And another comment is, we recently did another study ourselves, which was on skin disease diagnosis. And we were able to show that in that case, there is no difference in performance across different skin tones, which is different than what we see in other tasks. All right. So just to conclude, we're already getting very high accuracies on many narrow tasks using AI, but we need something more for high stakes applications. And what more we need is things like safety, security, and transparency, and that leads to a very broad sort of research and development agenda that we're very excited to pursue. So let me stop there and take any questions that anyone has.
Come on, I know this group is not shy. Ask him anything.
Yeah, please.
So this is Dave Hathaway.
Mhm.
I being a science fiction geek and having
Mhm.
read things like I, Robot years ago,
Mhm.
I'm just reminded of plot lines in a lot of Asimov novels where
Yep.
the classic three laws of robotics
Yes,
end up with unintended consequences.
absolutely.
And what you're talking about, it sounds like, is the nitty-gritty details of all of that in real life these days.
Yeah, I think we've progressed since Asimov was writing it, and he foreshadowed, I mean, a lot of things that we're dealing with right now. So, in other talks that I give, I do include his three rules and his the 0th one as well. And yeah, no, I mean, I think that is very much the case. That I mean, doing good, not doing harm, so beneficence, non-maleficence. I think they're very important as we think about AI. Yep.
So I saw your comments about verification and
Mhm.
explanation and stuff. How have they started doing that? Do people have? I haven't seen a
Mhm.
presentation on, what, how the how do you present a verification algorithm?
Yeah, so on the verification problem with faces, yeah, so like I said, these days, all of these tasks are done using deep neural networks, and explanations are a growing sort of aspect to it. So it's an active area of research of how to explain these neural networks. The example that I had with the gender classification task highlighted, I mean, certain parts of the image.
Sure.
If
Yeah.
you had been doing the verification task, it probably would have highlighted a different sort of part of the image. So uh, and what would have happened, so in the example that I did show, it was consistent among all of them of what it was focusing on, which body part. But
Mhm.
in a verification sort of problem for every different individual, it would probably have focused on a different part, whatever was unique about that person that made
Sure.
them stand out from the background population. So it's certainly possible, and if people aren't doing it commercially, they should be. The technology is there to do it.
Mhm.
So, Kush, I understand that many companies have pulled out of actually doing this. They've pulled out of doing it as a marketable technology. They've not pulled out of general research on it, have they?
IBM has pulled out of it in research also. So we no longer have any researchers doing face recognition or any face sort of computer vision stuff. Amazon and Microsoft might be a little different, but at IBM Research, we have no one currently doing anything even on the research side.
Eventually, it will come back. Oh, sorry.
It might or it might not. I mean, like I said, it's kind of this human rights question, right? So if uh, if you're doing anything, I mean, and all of us, I mean, who have seen the IEEE sort of ethics guidelines and stuff, I mean, the first thing that we should do is think about whether a problem is even the right problem to solve, right? So if it's not a problem that we even should be working on, then we shouldn't.
What's the next big area for AI?
Yeah, so I mean, these trust sort of aspects are definitely one direction. Another one is that uh, kind of combining this neural network stuff, which has really, I mean, gotten very popular and very, I mean, really well performing in the last like 7 or 8 years. Combining it with more of like kind of the so-called good old-fashioned AI. So that was things back in the day that were much more kind of rule-based, based on expert knowledge and stuff like that. So trying to combine the two is one big area, I think, because each has its strengths, and the more kind of hybrid things that we can do, I think we'll all benefit from it. So the term that people are using these days is neurosymbolic AI for that.
Does that mean that Prolog will come back?
Maybe, yeah. No, I mean, I'm serious. Yeah, I mean, so there's this thing called probabilistic programming, which is a way to add sort of statistical or I mean uncertainty to actual programs and stuff. So I think I mean some hybrid of things like that certainly could be the case. Yeah.
You know, after you gave your talk to my class, one of the things that they really latched on was the Algorithmic Justice League and her call for, what was it? It's accountability and equitability in AI. I think that was the two goals that she's been pushing.
Yeah, yeah, absolutely. Yeah, so I mean, equity and equality aren't exactly the same thing. So I mean, there's this kind of thought that equality somewhat implies just exactly the same for everyone, but equity is meant to also overcome any entrenched sort of disadvantages that might exist. So it might mean that you have to do something special for some people and groups as well.
Are there any other questions we'd like to ask Kush?
No? So if any of you guys think of other things, if you're whatever in the shower in the morning and you have some really pressing question, yeah, just send me an email. So Judy or Kevin can pass it on.
So this is Dave Hathaway. I guess I do have one question, which is, and I'm not sure quite how to articulate this, but is anyone looking at trying to figure out how to let the AI system as it is learning direct the requests for new data sets? In other words, and I'm not sure exactly what I mean, but you know, basically go out and say, okay, you've given me some things that you didn't like. Let me get more examples that are like this, so I can learn. It's kind of like self-directed, you know, learning for kids.
Right, and Kevin just posted something in the chat as well. Does the AI know what it doesn't know? And they're actually related questions. So I'm glad that he asked that at the same time. So so one, I mean, big area that's just getting started in AI research, which it might be surprising for folks here that this hasn't been done so much, is uncertainty quantification. So these neural networks that we're talking about are really bad at knowing where they don't know. So they can't really quantify where they have more or less uncertainty. But if they were able to, then that would be an indication that in this part of the space, I should be acquiring more data and more samples, because I need to reduce that uncertainty there and do a better job. So that is definitely an active area of work and research. And somewhat relatedly, another sort of topic that people are working on these days is trying to see what you can do if you collect several different diverse data sets. Because a lot of the problems happen in machine learning and AI because spurious sort of correlations that get picked up. But if you have a diverse set of data sets all about the same phenomenon, what should be common across the data sets is the so-called causal aspect of what's happening, or at least the salient part. And then each data set would have differences in their spurious parts. We and others are working on methods to try to use these diverse data sets to build models that are only utilizing the salient features. And that's another thing that can be quite helpful.
Can you do something like, I'm thinking of, PCA, principal component analysis, to take your original data set and separate it into pieces that look like they might accentuate those kinds of differences?
Right. Actually, one of our former interns, she's a PhD student at Carnegie Mellon right now, and I just joined her doctoral committee, and not with us, but as part of her grad studies. She's developed this method which is able to, uses information theoretic concepts, and it separates out the way to think about it is PCA, but slightly different. And it separates out what are the sort of features or combinations of features that are relevant for fairness versus sort of the business impact or business need that one might have. So in the US, for example, these discrimination laws do allow you to discriminate if there's a business need. So one court case from several years ago was with firefighters, and I think the court case was named Ricci et al. What was happening was men were more likely to be hired as firefighters than women. And this was happening because there was a minimum requirement to be able to lift a certain amount of weight as a firefighter, and men were more likely to be able to do that lift than women. And so what the court ruled was that, yes, it is allowed to discriminate if there is a pressing business need for that application. And so what her work is able to do is actually take a bunch of features and separate them out in this particular way so that you have those different components.
Okay, thanks.
Any other questions or comments? Okay, well, let's thank Kush for coming to talk to us. You got thrown under the bus not only by Kevin, but by John Cohn as well. So we really appreciated that.
Well, thank you very much. Yeah.
Yes, thanks.
My
And if I'm in the shower wondering if the rise of the machines is going to happen while I'm in the shower,
yeah,
then I really need to be worrying about other things.
I'll tell you. No, I'll tell you what one science fiction author said. One science fiction author said the risk isn't that the computers are going to come for us; it's that the robots are going to find us irrelevant, like the way we treat ants. That it's that we will be an annoyance to get out of their because we're interfering with them. And but I think in the meantime, I actually really recommend the book. I actually have the book that you should. I have it sitting here because it's one of the textbooks for my class. And
She does.
no, it's really interesting to see the extent to which these kind of systems pervade your life and you're not really aware of how much they're being used to set your insurance rate, determine your credit score, college admissions, all of these things. Who gets interviews based on resumes?
Yeah, exactly.
Well, cool. Well, thank you very much, Kush. I think that was a wonderful talk. I really enjoyed it, and I'll never watch The Matrix quite the same way again. Because if you haven't figured it out, Kevin and I are both very much science fiction fans. So what was science fiction in the 60s is now becoming, relevant things that are happening. So I think it's pretty cool.
Yeah, all of us are inventing the future. And I think that's the IEEE tagline, something like that. So, yeah.
Right. Thanks.
Yeah. All right.
All right. Well, thank you, Kush.